Always like presentations at the end of the week. It's been a heavy week, but a very interesting one, especially uh, on enterprise AI. So today's topic, I just wanted to say lecture because there's actually a lecture after this one that I need to attend. Uh, so the presentation is going to be about setting up an agentification factory. I am Mark of Nurne. So I've been in machine learning since 2008. That's a long time ago. And um, next to building AI organizations, I'm also a lecturer where I teach machine learning data science to non computer science students. So that's what I like to do as more like a hobby. I'm with them, we have formed a research program that we have been at since the last 1.5 to 2 years. And I will be talking a little bit about that because it's about enterprise AI. I'm also starting a PhD on one of our own papers. So that's quite cool. I will be talking about that paper as well because it is a new type of AI model. And last but not least, so the research, I've set up a research organization, enterprise AI research, applied research, which is called Eigenvector. And we have a customer, which is ASML, and there I am running an agentification factory at scale. So it is not only a bit of theory, it's mostly applied knowledge. So how have we applied our knowledge on agentic AI into practice and running a profitable agentification factory at scale? And basically, what I've set up is a research led program, which I will be talking about how you can set that up, but also what the experiences are. Yeah, so with Eigenvector Research, we've been studying enterprise AI for the last 1.5, 2 years. And so we have produced about 14 papers. And the last one is a new type of uh, AI specifically for agentification, which is called a coordination model. And that is because a large language model is basically not fit for agentic AI. So I'm working on a blog that will air on Monday, in which I will tell exactly that story, why an LLM, so like the generative AI that we have come to know, is not the right type of tool for enterprises. So I've also started an initiative called Atlas, and Atlas stands for Autonomous Tasks and Long Horizon Agentic Systems. It is a research hub specifically for agentic AI. It contains 1,700 research papers. It's fully AI driven, this platform, and it's mainly for agentic AI research. And this is the factory that I'm running at ASML. So ASML, the Dutch lithography organization, where we are currently automating a lot of processes. So we have a repository of 1,500 processes, of which we have around 300 in our pipeline at current, which we take through a process consisting of an intake, analysis, and improvement. Then three totally different factories on automation and identification, an SAP factory, Microsoft-based factory, and something we call hyper automation factory. Then there's a new type of work stream. Well, there's a work stream that I call compliance and value, but I call it the evidence factory, in which we look at operational processes run by agents. Now, where did my whole journey start? It started with the research program called NCC 1701-AI. That is a nerd joke. That's actually um, the call sign of the first Enterprise starship. If you know Captain James T. Kirk, the Starship Enterprise, that is his call sign, NCC 1701. And of course, the starship was called Enterprise, and his slogan was to boldly go where no one has gone before. And that is actually what we're doing with our research program. I'm actually calling it the frontier of unsexy AI. And why am I calling it the frontier of unsexy AI? Because I'm talking about enterprises, right? Enterprise AI is beige. It is not as sexy as a 1.6 trillion hyperparameter model that Kimi brought to the market, or a harness like Hermes and OpenClaw, or world models where types like Fei Li and Young LeCun and Dennis Hassabis, the three gods of AI, they're now saying, well, LLMs are of the past. We want to focus on world models. Those are the sexy frontier labs. I am not running a sexy frontier lab. I'm running an enterprise AI lab. So an enterprise is not about flashy demos. It is not about quick wins and deep troughs. It is about predictability, incremental steps, and incremental growth. It's like a mammoth tanker, an oil tanker that you have to steer. So I am not working on cool harnesses that run on laptops, the OpenClaw style, um, the OpenClaw style harnesses that you can do lots of cool stuff with. And I do that myself. So as you can see around me, it's a nice home lab that I've built with a lot of cool tech on which I'm running. So to the right of me, you can see a stack of Mac Studios that have a Hermes cluster running on it. And to the left of me is a world model. That's VGPA, Jan LeCun's world model that I'm currently testing. I'm not working with LLMs anymore because LLMs are something of the past. But predictability is what you need in an enterprise. And you need something that you can govern, especially in Europe, because the rules and regulations are really stringent. And when we started our program about a year and a half ago, me and my students, we went out and we ended up with 200 organizations that were already deploying agentic AI. Agentic AI, by the way, when I'm talking about agentic AI in the case of, in the context of a factory, I'm talking about autonomous processes or semi-autonomous agents. So not chatbots. So especially not chatbots. It can initiate an autonomous agent, but it is not an agent in the autonomous definition of the word, because the industry is creating lots of confusion when it comes to the term agents. We still call a chatbot, and when we talk about an agent, we are talking about autonomous agents. So we found about 200 of these companies, and we ended up with 177, which we followed for about a year. And we learned a lot by studying their behavior and their programs. So one of the things that we learned were the failure modes. So, of course, and that is, I'm not sure what your background is, but we all know that agentic AI is depending on the data you feed it. So basically, if there's crap in, you get crap output. So it doesn't, uh, it isn't weird that the number one issue was data quality issue. So that is something we expected. But number two failure pattern was governance failures. An organization, an enterprise needs to be governed. It has controls and laws that you need to abide by, like NIS2 and the AI Act and DORA and the data acts that we have. So, but the thing is, nearly a third of organizations that were running agentic programs, they failed and had to stop their agentic program, not because they failed at governance, but because the cost of post hoc interventions, and with post hoc, I mean an agent generates a result and the result is wrong for some reason. A operator has, or a process owner, or someone looking over the agent has to intervene, maybe roll back the results, correct everything that was wrong. And when the cost of this intervention in a repeated fashion, when the compounding effects of that action exceeds the value that you generated for, because that's the reason why you're running agents, right? It's because simply it's automation. But when the cost of interventions is larger than the value you generate, then basically you may have automated something, but you have lost money. So, and that's why one of our disciplines, we actually have three pillars in our research program. It's cost, control, and quality. And around all those pillars, we have created papers. Around the cost component, we have created this new discipline that we call agentic economics. It's a whole framework of how to look at value throughout your factory, and especially to share learnings among operators of the various factories around the world where you can save money. And I will share a few of them, but the most important things where I save money is labor cost. Yes, because the cost of people building agents is very high. And we are working with three universities, all the three technical universities, who are supplying students. Well, students, they are not the most experienced people, right? So that's why uh, they start as a junior. But the cost of students is quite low. They are highly trained, and they get job experience, work experience by doing the work they're supposed to be doing when they're trained in our factory, and they cost less than a regular developer does. So that is a big cost factor. And the second cost factor is that we're not using frontier models. Frontier models cost between 30 and 50 dollars for a million output tokens, and that is just too much. Because what we have learned is that the ROI, because we are in the black and not in the red, but we do that because we know what not to do. And I'll explain that later. And because we keep the cost down, and therefore not use frontier models, we're able to have our program run in black numbers instead of turning a loss. So when we studied these processes, we came to the conclusion there are 4 zones in which we found those processes. And these zones have been adapted by Microsoft recently. So that's quite cool. So they're now advising a zone-based deployment strategy. So zone 1 is what I call personal productivity. These are automations that you do on behalf of only yourself. It is like you have an agent that looks at your emails, does triage every day, and picks out an email that has data that you find interesting, uh, extracts it, and puts that in an Excel that you're monitoring, right? So that is an efficiency that is only important to you. So that is personal productivity. We have learned that there is a max efficiency to those types of automations, and that is maximum between 0.1 and 0.3 FTE, which is the hours saved by these automations. So these type of automations is not what you want at scale, because you are spending more time than it yields. So more time building than it yields. So you need something, what we call a citizen developer program, which we are in fact running parallel to our agentification program, to stimulate your employees to create agents themselves. And for that, you can use, for instance, Copilot and Copilot Studio, because every enterprise has Microsoft. Copilot Studio isn't the best platform, but it's abundant, and you can allow end users to create personal automations. That is what we're doing as well. We are not blocking that. What we're blocking, though, is Zone 2 for end users. Zone 2 is what I call bounded autonomy. Um, and these are processes that are low risk, have a limited number of variations and edge cases, not so many people involved. They are short horizon steps, so a few steps, task steps, I mean, for an agent, and they always end in a human in the loop. So a person looking at the results of an agent. So this is a semi-autonomous workflow. Um, there is about 1 to 2 FTE savings to be made with these types of agentic processes, these semi-autonomous or bounded autonomy workflows. Now, then there's Zone 3. Zone 3 is the reason why these 30% of organizations failed their programs. Because this, in Zone 3, we are talking about whole L3 level processes, multi-step, long horizon processes they tried to automate that had lots of people in it, were risky processes, high value risky processes, multiple edge cases, variances. Um, and when they introduced agentic AI into those types of processes, well, the agent simply broke down. And there are a number of reasons that I'll touch on later why an agent breaks down in that zone. But what happened is, because they broke down or they produced wrong results, is that a person, a process operator or an employee had to intervene. And as of that moment, the cost of intervention, that ticker started ticking, and led to a negative value. So what we are doing in our program is we are parking Zone 3 type of processes. There's a way around it that I will explain a little later on. But nearly 1/3 of the organizations failed, um, sorry, had to stop because of the cost of compliance. But it is also that 70% of all the attempts to automate these types of processes failed. So it's not only the cost that is higher, but also that they failed in their attempt. And that is because long horizon agentic workflows are simply impossible. And that's why I created Atlas, because I want to know what the status of the research is on that zone. Because whenever the research is ready, we can start automating them. And that is the reason why I have created a new model, which I call the coordination model. It is basically not an LLM. It is a new type of model that predicts coordination states, and it is trained on processes and on governance constraints, right? So it knows governance, it knows process steps, the same way like geometric AI knows that this is a cup and it has an ear, and when you turn the cup, there is still an ear at the back. So an LLM doesn't know that. So this is why we built Atlas. Now, and then there's Zone 4. Zone 4 are basically processes that are going to be human for a long time. Like, for instance, would you like to fly in an airplane that is basically flown by an AI agent? Well, most people will say no. And that is true. I don't want to fly in an LLM flown plane, right? But you have to know, by the way, that an airplane does have AI at the helm, and it is a different type of AI from the 80s, which is called symbolic AI, and that is very predictable. It is not unpredictable the way an LLM is, because that is a probabilistic model. It's like rolling the dice. And when you roll the dice, there's a chance that it might not roll in the direction you want it to. So zone 4 is the type of processes that we park. Well, this is the we've created this technique which is called the pass score, and you can find everything that I'm talking about, including white papers, on the Eigenvector research website. So this is called the pass score. It's part of a one of our research papers. It's a way how to determine in which zone a particular process belongs. So zone 1 is automate now, with a very high pass score, but it does not yield a lot. So we tend to, because when we started, we built a lot of those zone ones simply because we wanted to give our influencers that want to build automations themselves, we wanted to give them examples, but you're not going to make a yield, you're going to lose on them. And we are now mainly focusing on zone 2s. We are parking zone 3, and we're archiving zone 4. Well, this is one slide that I want to show you about agentic AI. So I hinted on it when I started. So this agentic AI is not like binary. It is a continuum, because it's not one solution. It's a continuum of different solutions. On the one hand, you have chatbots or assistants with lots of human oversight. That's the dimensions below that. But it is not autonomous at all. And on the other hand, you have autonomous systems, which are on the other end of the spectrum. And a good definition of that would be a zero human company. An organization, sometimes also AI native organization called, that is an organization that runs without humans. I actually thought it was impossible until a few days ago when I saw a particular technology that changed my life overnight, in the same way it did when ChatGPT arrived in 30 November 2022. So at the same moment, enterprise AI is going to change, and that has a lot to do with 4 and 5 autonomous systems and autonomous agents that are able to conduct long horizon execution. So this is when someone in the organization starts talking about agents, I first want to know, what is your definition of an agent? Are you talking about a chatbot, right? Like ChatGPT, Copilot, Claude, Gemini, or what have you? So these are, this is what the industry says is an agent. Or are we talking about controlled execution through a workflow agent? Could be, again, Copilot Studio or these guys. So anyways, that goes on. And my advice is stay for now in zone 2. Zone 3 is fully autonomous operations, long horizon execution, but I wouldn't go there. So the trick is to build trust in your program. And you do not build trust by, I wanted to cost a little bit, is by doing things wrong. So you have to be careful. Therefore, I would say always start with uh, bounded autonomy. Basically, when you're using Copilot, for instance, do not build autonomous agents. Start with Copilot-based agents. They are the most simple agents you can have, and there's always a human involved. Even if it's multiple steps, there's always a human involved. And here you cannot make a lot of mistakes. So we are doing this thing called differentiating control, or differentiated governance, meaning that zone 1 doesn't get to have any governance at all. Zone 2 gets limited governance in the form of controls baked into the technology. Zone 3 is not allowed at this moment, but when we are allowing it, it will only be centrally built. End users will never be allowed to build autonomous agents, and it's simply because of the complex nature of the controls involved. So that is differentiated governance, and the reason why we're doing that is because then you get to assign cost, because governance costs money. as I said earlier, then you get to assign different regimes to the different types of agents that you have, and that saves you money. So we're not are building autonomous systems yet. That is what I call the economic trap of Zone 3. You're going to fail. They are different because of one thing. This is the most thing that people do not know, but um, if your model has, well, this thing calculates in steps of 5%, say it has a 1% chance of making an error, which is the typical thing, right? And I'm not only talking about hallucination rates, I'm just talking about a model doing things wrong. And uh, it is quite low, the error rate. But when you're talking about agentic workflows, the error rate goes up quickly. So that's one disadvantage. But say you have a 1% failure rate. 1 in 100 is okay, right? If it's for you yourself. Um, and for a company, that's the same, right? So if it only means that in 1 out of 100 cases, you have to intervene, that is quite reasonable. But in a multi-step workflow, that compounds. It is actually, it um, uh, grows quadratically. I wouldn't want to say exponentially, but it is compounded. So in a 20-step workflow with a 1% error rate, 3/4 of the processes that you're running are wrong. They are wrong. I mean, they produce the wrong results. And that compounding effect is one of the biggest reasons why long horizon agents simply do not work, or long horizon, shall I say, language based agents do not work. Then there's a lot of issues related to the harness. A model is a network and the attention mechanism that is in front of that. And some people would say the embedding is part of that as well. And around that, you have a lot of scaffolding, which we call harness, that contains a context engine, a memory, tool calling, workflow stuff, and lots of other things that the frontier guys built around a typical model. Well, one thing, and when you're running, say, Hermes yourself, I ran into that problem pretty quick, is this thing called context degradation. Context, you have to know that an LLM, an AI, doesn't have a memory, right? So you have these things called context rot and memory degradation. An LLM doesn't have a memory. It always starts from zero. And um, every time you start another action, you have to feed it with your prompt, the stuff you type, plus the context around it, what it did before. Because when you're running a multi-step workflow, it needs to know which steps it already did before. So it needs to plan for the next step. So that um, the thing is, when the context grows, because when you have hundreds of steps, you can, you can imagine that the context grows, and the percentage of text that makes up your goal for the next assignment is shrinking in percentage. If you have, say, 500,000 tokens worth of context and only 500 tokens worth of prompt, then the percentage is shrinking with the amount of context that is growing. So you always have to build what I call a memory architecture. I'm these days building memory architectures of 5 layers because you have different sorts of memory. But anyways, this is one of the problems. So context rot and memory degradation, but also tool calling breakdowns. Not only breakdowns, but they can start looping in a tool call. And the thing is, they will burn tokens while doing that. So as part of agentic economics, or Dutch tokenomics, as I'm calling it, because I'm Dutch, and us Dutch are known because we are frugal, and this is the only way, I would say, that we can use it to our advantage and to the advantage of the entire globe when it comes down to agentic process automation, right? So because we have to really take care of the cost that we are making in our factory, because indeed the ROI is fragile. And the reason why ROI is fragile is because we are focusing on zone 2 types of agents. And the reason why we're doing that means that we have a fragile ROI, we have a low ROI, but at least we are not dead like other programs who were focusing on zone 3 because they simply didn't know or didn't have this knowledge before they started. So tool calling can cost you a lot of money. Well, this is also a reason you have to spend a lot of time auditing stuff. Um, and irreversibility for zone 3 is a issue. So with irreversibility, I mean that when you have taken a step, then you cannot reverse that step. And that is a factor that determines if a process belongs to zone 3. So irreversibility is one of the reasons why you will have processes that will break down, and you will spend a lot of time and money reversing the problems. So yeah, this is the cost of human intervention. That is the lesson. You need to remember the hidden tax on agentic AI. So zone 3 costs money. And when you start a factory, you have to build trust instead of maximizing autonomy. So that's something you have to build towards. And that is why we are in practice chaining zone 2 workflows. So typically a zone 2 workflow resides at the L4 level. You have different levels of processes, L1 through L5 usually, where L1 is the top level process and say finance, and the L5 is a work instruction. And for an agentic project, you need at least a high level F5 description of your process. But a zone 2 is typically in practice an L4, a simple L4. And what we do is we chain multiple zone 2 workflows together, all separated by human in the loops. And so we chain them together so as to form a automated L3. But then they still have a lot of humans in the loop, which is a costly thing. And first you need to build trust. So go build these zone 2s and then slowly remove the humans from the loop. So when you've removed a human out of the loop, retest it, follow the process for a while. So have your agentic operator. It can be run automatically. It doesn't have to be a human all the time, but that needs attention, monitoring, if the workflow is still stable or has degraded. So how do you set up this AI factory? Because I was now only describing um, a technique that we use in our first work stream, which is analysis and improvement. So step 1, 2, and 3 are basically part of that work stream. So then there's the work stream automation, which we have 3 parallel factories. So hyper automation, we're using Camunda. Microsoft is, we're actually running a hyper automation factory across the board because we're not only using agentic AI or regular AI, but we're also using traditional automation techniques. And that is because sometimes traditional automation techniques are way better than agentic techniques, because sometimes you just need to make sure that 100% sure that you can repeat the process in the same fashion without it breaking down. And agentic AI always has an error margin in it. So we use RPA. We even use Power Automate, which is a very potentially cost-effective tool. And it has proven itself multiple times. It is nearly free. It is free to use. But if you want to govern it at scale, you need to have this thing called the Agent 365. You need it You need it sowieso, as we say in Dutch, because otherwise you can't manage your studio agent. And then there's SAP with SAP Joule, which is their way of generating agents, because you have to work across ecosystems and you have to monitor that as well. So that is what we call the evidence factory, where we monitor all the agents in production. And if I have time, I will talk about that as well. So an agentification factory is not like this technological foundation. Yeah, you need to have the technology to build agents, but it's basically a way of working. It's the way how people work together on process improvement, on governance, how we do economics, how we set up reusability. And the advantage of running a factory is this is where you get the advantage of enterprise AI at scale, because it all revolves around reusability. Reusability of technology, and in case of agentic AI, it's reusability of patterns. Once, when you build an agent or a pattern, you can reuse those agents and those patterns, and that saves you time. So, and the compounding effects of not having to work with tens of different scattered pilots across the organization, but just focusing it in one factory, plus maybe this citizen development program that you're running next to it, is that you can do it very efficient. And when you combine that with knowledge of agentic economics, you will have ways to run your program in the black. With everything I do, I produce documentation. So when you go on Eigenvector, you will see the research papers, but also white papers, how to build an agentification factory, how to do zoning, how to build an evidence factory. I have plenty more papers that I still need to find time to put on Eigenvector. I write about it at Tectonic Shifts, which is a blog on Medium, LinkedIn, and of course my own blog, in which I talk about the different elements of running a agentification program at scale. So what do we do in these work streams? So intake is basically where we collect process ideas, and we only accept them if they have a value associated with them. We started at first with collecting process ideas from the organization. And at one point in time, we had roughly 300 candidates in the pipeline. But that meant that our energy was highly scattered across all those different initiatives. And even though we were driving candidates through the funnel, it was slow. So once we had established a working machine and established a bit of trust, we had shifted for a few customers to top-down based process selection. So that is the change you have to make. So you can start with collecting process ideas to test your machine, to test your usability. But the main advantage is when you start switching to top-down process selection, because there you can make use of technologies like, for instance, Solonis, that is a process mining technology that can help you identify where the most value cases lie. But you can also, if you haven't got technology like that at hand, you can also use the intuition and the experience of the managers involved. So we did that. We asked our managers, so we have ambition now, we want to scale, and we do not want to scale in the number of smaller initiatives, because we mainly had zone 1 and zone 2 initiatives, but mainly zone 1s, which, as you now know, do not yield a lot of margin. So you basically lose money on them. So we wanted to switch to high volume zone 2 processes, which we call the zone 2 plus types of processes. So, and we are doing that now. So we can focus entire teams on 1, 2, and now 3 major processes that we're going to agentify in a long stretch. And we are using techniques like value management. So as part of agentic economics. I've created this um, discipline called round trip value management that I've written about. There's a white paper on it, and it's not complicated. It's economics, and it's just simple Dutch farmers' knowledge that we apply. It is not high math, not high engineering knowledge. It's just simple economics that we apply and simple wisdom on how to select for the most valuable cases and what to do and basically what not to do. Another learning was that there always needs to be ownership from the business. So we now make contracts for these top-down processes. We have contracts. We do not sign them. It's not a legally binding contract, but in which we describe the process, we describe the value, we describe the cost associated to it, not only to create the automation, but also to rationalize it, the operations cost. And then the process owner, which is all the way up to the manager that owns the process, and they're delegated SMEs, etc., but they're not in the contract. So it's between me, the process owner, and one or two other people like the value manager in our team. And we agree on getting this value. Well, and the advantage is that by doing it this way, not only the contracting thing, but focusing top down, is that you get the focus. You get the focus of the manager. You get the focus of the people on that one big process, instead of scattering all the focus across 300 initiatives in your pipeline. And that, on the long run, doesn't work. It's good to get ideas in, to test the pipeline, to test the machine, to test reusability, but you have to quickly switch and get what we call big, hairy, audacious goals, where you have to prove your worth. And we are now at that particular inflection point. So proving our worth at scale, high value processes. So yeah, that's basically what we do in analysis and improvement. We are analyzing processes before we automate, but we are not only analyzing them, we are eliminating waste, simplifying, standardizing, and improving processes, because we are not um, uh, uh, automating broken processes. So that is what we call SI. That's elimination, simplification, standardization, um, improvement, and automation, which is basically the steps that we go through. So yeah, this is basically the level that I talked about. L4s is where you will find most zone 2s. The organization that tried an L3 with a long horizon agent, they failed. So what we do is we pick out L4s and we automate them with the human in the loop, and then chain them all together horizontally. And so we form an L3. So the picture's not entirely accurate, uh, because there are multiple arrows from L3 to L4, but you get my drift. I explained that. So at the end, there's a solution design. So there is one or two people that are designing the automation. So the different combination of technologies like RPA, do we need the deterministic technology, or can we use probabilistic technology like agents? And what types of workflows do we need? What types of patterns do we need? An agent can work on its own, but it can also work in a multi-agent setup. That could be like, for instance, a React pattern, which is an agent that is only reasoning or planning, and others are executing. And for that pattern, we do use a frontier model, but only for the reasoning agent. So in our harness, we are able to discern between an agent that is reasoning and planning, and for that we route it to a frontier model, which costs $30 to $50, 100 million. Only input is also costly, but less. And for reflection pattern, for instance, that is when an agent thinks about the results of its actions so that it can learn. So that is what you define here. And if you need an external orchestrator, because when you are growing towards more um, professional setups and more lengthy processes, so you are investing more in that sort of technology. By the way, I'm looking at the clock. I see it is 18 minutes past 4, and I'm not sure if I have totally forgotten time or that my clock is wrong.
Your clock is okay. You still have a couple of minutes to finish your presentation. Please leave like 10 minutes and then we have a couple of minutes for questions.
So my clock says 18 minutes past 4.
Yes,
Am I right?
and that's correct. And you still
Oh.
have like 12 minutes to go.
Okay. So, but do we have questions after the 12
Y-
or?
We have questions after, yes.
Okay. So I will finish what I'm doing. So evidence factory, there's only one slide that actually few. So evidence factory is basically where you collect information about the agents that are running in the operations. So which is called telemetry collection. So you get information. Then there's the layer it's called observability, where you watch the agents. You can do that automated or with humans, which we call agentic process operators. And when it goes wrong, we call them poop scoopers, agentic poop scoopers. So that's the observability and explainability layer. Explainability meaning you have to explain why things went wrong. Why did they go as they went? And that is also important for auditors. So that's the observability layer and a process intelligence layer. So this is actually the layer where you look at the agents. You have your kill switch. You have your insights, cycle times, throughput, that sort of stuff. That the agentic process operator operates, and there is where he or she can intervene. But the moment that person intervenes, then the timer is started. And then there's one layer on top in which we continuously calculate the net program value. So this is a hard part to build. So we started with Excel and Power BI and Power Automate and that sort of stuff. But there's actually cool technology on the market nowadays, and it's going to go in general availability in October. If you have the luxury of running Solonis, the process mining tool, they will have a new technology called Apollo, which is basically covers 80-90% of your requirements. It can calculate uh, the program value per agent based on the actual telemetry and the time you spend as a person intervening on it. Yeah, so evidence in our factory is even hashed through a what's these things? These tokens, cryptography. So it is the foundation of trust. So we cannot change the elementary telemetry. So what you're doing in the beginning is building trust, because yeah, it is quite hard to get agentic ROI and to make sure that it works. Yeah, and one of the things in the last minutes, because I will send you the slides if you're interested, is that we are going to introduce a new type of model. I have a book on that and a white paper if you're interested, and we are building it as we speak. I call it the end of LLMs. An LLM stands for large language model. It's basically only language. It. It has an internal representation of the world only in words, so it does not know an object apart from the 5 letters A or six and adjacent semantic concepts. Like I have a water bottle here and a beaker here. Those are two adjacent concepts that the AI has in its internal representation of the world, which is called the world model. But what it doesn't know is that indeed, when you rotate this cup, the ear will rotate with it. It doesn't know that. Cannot do that. Um, a diffusion model cannot do that either. It A model like Nano Banana does that because it is brute forced on millions of photos, so it has an idea what to do, but it cannot calculate that. So that's why you have different foundational models called geometric AI that really knows an object is an object, that a human is a human, that a kidney inside a body has certain dimensions. And AlphaFold, where the builders of AlphaFold got the Nobel Prize of Physics last year or 2 years ago, um, they built this prediction model for protein folding. They tried it with an LLM, but it failed. And so I'm seeing that an LLM really doesn't perform in agentic AI. And that is the main reason, apart from the harness, it's the error percentage that just kills your ROI. So you can have black ROI in the black if you follow, the steps that I'm writing about. Um, but the thing that is going to work in the end is a different foundational model. And the thing is, I'm seeing this happening all around me. In a short period of time, Google today and yesterday launched two new foundational models, Tensor FM, and the other was another foundational model, something on arithmetic. And these are models that are trained on a specific task. Like, for instance, a lithography machine generates terabytes of data each day. You can train a model on that, and the model then will become a brain that thinks like a lithography machine. So if you have a machine that produces gigabytes a day, you can literally build a brain that thinks it is that machine. And so we set out to build a model that thinks that it is a business process, that it is a governed business process. So yeah, and that is something we did. We called it the coordination foundation model. And yeah, this is the book. It is not available yet because this is the preprint, but the white paper is, and you will see more of it within a number of months. So this is what I've said. It sees the world as a different thing, and enterprise processes are coordination systems and not language system, because a language model predicts the next word. And it's an autoregressive word prediction machine, and a coordination model predicts the next action between nodes or steps in a workflow. And it's simple when you think about it, but most people didn't think about it. And that's why the gods of AI, Fai Fali, Jan LeCun, are all going to world models, because they know that the era of large language models, at least in the enterprise, are past us. So yeah, it's the end of LLMs in the enterprise. And then there's still some room for a small language model, because around the coordination model, you have to talk to the thing. So yeah, there is still use for a small language model just to talk with it. That's why you're ending up with a mixture of experts. So I'm going to leave it with that, so we have a bit more time for questions. Um, yeah, so I think you guys, let's do the questions. I'm gonna stop broadcasting.